Okay, so probability. So if we just look at probability in general. Now, probability runs from 0 to 1. Okay, so if something has a probability of 0, okay, it will not happen. Okay, so this will not happen. If we have a probability of 1, it will happen. Okay, so for example, if I was to toss a coin in the air, then the probability of it coming up heads or tails is a probability of 1, because the coin can only do that. It can only come up heads or tails. Okay, now sometimes in an exam they might say, okay, given this scale from 0 to 1, where on this scale would you expect the probability to fall? So for example, if a lady falls pregnant, the probability that she has a girl, okay, would be around about here, okay, about the halfway mark, because she can only have a boy or a girl. So the probability would be a half, or 50%, or 1 in 2. Okay, so probability of something not happening, 0. Probability that it will happen, 1. So all probabilities then must be fractional. Sometimes they're written in decimals, but generally we tend to work in terms of fractions. So if we had a coin and we spun the coin, as I said before, we only have 2 probabilities. It can come up heads or it can come up tails. So the probability of it coming up heads would be 1 in 2. So this would be a half. Okay, 1 in 2. Probability of it coming up tails, again, 1 in 2. So this brings us on to the next point. All probabilities add up to 1. Okay, this is important for you to remember. Sorry it's not printed very well, but all probabilities add up to 1. As you can see here, probability of getting heads is a half. Probability of getting a tails is a half. Now if I add these 2 probabilities together, I get 1. So all probabilities add up to 1. Now usually with probability questions we get something that we call a tree diagram. So we have here a tree diagram. Okay, and you've probably seen this in the classroom or you've seen it in textbooks, and we use this to work out probabilities. Okay, so for example, let's say we have a bag here with coloured beads in. Okay, and yes, I know as an artist I'd probably make a good mathematician, but we have a bag here with some counters or balls or whatever, and we have 4 blue and 3 red. So if I was to put my hand into the bag and draw a counter, let's say blind, and note the colour. So if I was to put my hand in and pull a counter blind, the probability of it coming out blue would be 4 of the 7 counters. Okay, so I can say here that if I chose a blue counter on my first choice, it would be 4/7. Now, the probability of me pulling a red counter would be 3/7. Okay, and I know this is right because all probabilities add up to 1, so 4/7 plus 3/7, 7/7 is 1. Now, what's important is, do I replace these counters or not? So let's assume I replace them. So I take a counter, note its colour, and then replace it. Okay. So if I've chosen a red counter, so I just go along this line. Let's say I've chosen a red counter on the first go, and then I've replaced it. My probability of pulling a red counter again would still be the same because all the counters are still back in the bag. So that would be 3/7. And if I'd chosen a red counter and then replaced it and then chosen a blue, this must be 4/7 because everything stays the same. So equally, if I'd chosen a blue, replaced it, and then chosen a red, it would be 3/7. And if I'd chosen a blue, replaced it, and then chosen a blue, that would still be 4/7. So now we can see that we've worked out the probabilities for each turn. So for example, if the question was, what's the probability of pulling a blue and then another blue, okay, we can work this out, and we use something called the and or rule. So we have and or, and we're looking for these in the sentence. So if we were choosing a blue and another blue, then we use and, obviously, because that's it. Now if we see and, it tells us to multiply. If we see or, we add. Okay, so a blue and a blue, and says we multiply. So this I just use like a road map. So a blue on my first choice would be 4/7, and then a blue again would be 4/7. So this would be 4/7 multiplied by 4/7. So this would give me, remember we multiply straight across, so this would give me 16/49. And that would be the probability. Even if you can cancel this, we tend not to, but it doesn't matter, it's fine. As long as you get a final answer that's fractional, you know you're right. So for example, let's say the probability of pulling a red and a blue. So we have and in the question, which means we multiply. So the probability of pulling a red, so on our first go, a red would be 3/7. And we know we're going to multiply. So a red and a blue. So like I say, this is just the route map. So a red and a blue. So the blue would be 4/7. Okay. So again, 3 4s are 12 and 7 7s are 49. And that will be the probability of a red and a blue. You don't have to work out all the probabilities, only answer the questions that they give you. Okay? So the only other thing that they could ask you sometimes is they will take the words and or sometimes out of the question. So you then need to rewrite the question. So for example, let's say they say the probability, so P, the probability of choosing two counters the same colour. Okay, so the probability of choosing two counters the same colour. Now we can see here that it doesn't have and or in the question at all. So what we need to do is rephrase the question. So if we have two colours the same, that would be a blue and a blue, or a red and a red. So this will be a blue and a blue, or a red and a red. Now we have the ands and the ors in there. So a blue and a blue. Well, we work that out back here, 16 over 49. So I know that's 16 over 49. Now or means we're going to add whatever the probability of a red and a red is. Now a red and then a red, this will be 3 over 7 multiplied by 3 over 7. Now 3 over 7 times 3 over 7 is 9 over 49. So now I just add these two together. So 16 plus 9 is 25, and that will be 25 over 49. Remember, you only add the numerators, not the denominators. So that will be the answer. And they're very fond of this, choosing two colours the same, by taking out and or from the question. So you just have to rewrite the question so that you know where you're going to multiply and where you're going to add. Okay? So hopefully you can see it's not too difficult. What's important is you know the and or rule. You know all probabilities equal 1. So a probability of 0 will not happen. Probability of 1 will happen. Okay? And then tree diagrams, here we've replaced the counters. So you'll see that it will always be, doesn't matter how many times you choose, it will always be 3 over 7 and 4 over 7. Okay, so I'll do probability number 2 where we don't replace, and we also look at relative probability. Okay.